Hello everyone. I welcome you all. I welcome you all to today's video lesson. Now on the board, we're having questions which is calculations on mole concepts. Number 1 says that what volume of CO2 is produced at STP when 50 grams of limestone reacts completely with excess HCl. Calcium is given as 40, carbon is 12, oxygen is 16. The GMV, which is the given molar volume at STP, equals to 22.4 dm cube. And the equation for the question is given on the board. So we are having calcium carbonate reacting with hydrochloric acid to produce calcium chloride and water and carbon 4 oxide. So you have calcium carbonate reacting with hydrochloric acid to produce calcium chloride, water and carbon 4 oxide. We're having 2 here. So the equation we are having right here is a balanced equation. It's a balanced equation. 1 calcium, 1 calcium. 1 carbon, 1 carbon. 3 oxygen, 3 oxygen. 1 plus 2, that is 3. 2 hydrogen, 2 hydrogen. 2 chlorine, 2 times 1, 2 chlorine, 2 chlorine. So the equation here is a balanced equation. Now, let's go to the question now. The question says that what volume of CO2 is produced? So, if you have been watching my video lesson, in this calculation, or let me say when it comes to calculation like this, our attention will be drawn to just 2 substances. Now on the board we're having 5 substances: 1, 2, 3, 4 and 5. But even though there are 6, your attention will be drawn to just 2. And the first one will always be the unknown, the one you are asked to calculate. And the second one will be the one having value, So amidst the 5 of these now, which 2 are we relating? The first one now, what volume of CO2? So CO2 is the unknown, so we have to calculate something about CO2, and the question says what volume of CO2. So CO2 is the first one. Now which one has value now? Is produced, what volume of CO2 is produced at STP when 50 grams of limestone? So you can see limestone to be having value, and the chemical formula of limestone is CaCO3. So CaCO3 is having value, so we are having CaCO3. So we are comparing calcium carbonate and carbon 4 oxide. Now, before you go into the question, always derive what you make use of to get your answer from the equation. So first of all, relate what you have from the equation, then you now apply the question. So from the equation now, what are we having now? So we're having 1 mole of calcium carbonate reacting with HCl to produce 1 mole of carbon 4 oxide. So we're having 1 mole here also. So this is what we are making use of to get our answer from the question we are being asked. We are having question here. Before we start solving the question, we must first of all bring out what we are going to make use of to get the answer. And what we are to make use of is always from the equation. So what happened here? 1 mole from the equation, 1 mole of calcium carbonate produces 1 mole of CO2. Now, with that being said, are we going to leave these ones here as mole? Are they asking us in mole, or they are asking us in another unit? If they are asking us in mole, we leave it like this. If they are asking us in another unit, we have to convert this mole to that unit they are asking the question from. The unit they are asking the question. Now, as we can see, question 1 says that what volume of CO2 is produced at STP? So what happened here? We are looking for CO2 in volume. We are looking for CO2 in volume. So now, we're having 1 mole of CO2 here. So at STP, now take note, 1 mole of any gas, 1 mole of any gas will occupy a volume of 22.4 dm cube at STP. Any gas at all. And 1 mole of any gas will occupy a volume of 24.0 dm cube at RTP. So we're having STP on the board. Now, 1 mole of CO2, but CO2 here is a gas. 1 mole of CO2 occupies 22.4 dm cube. 1 mole of CO2 occupies 22.4 dm cube. Now, so it means that we are attributing this volume to mole. So instead of us having mole here, we do what? We impute volume there, because the question is coming in volume for CO2. So we're having 1 mole occupies 22.4 dm cube. Now, for calcium carbonate now, are they asking us in mole or they are asking us in another unit? Let's check. When 50 gram of limestone, so what happened there? They're asking us question about limestone in what? In gram. And gram is a unit of what? Of mass. Of mass. So one mole of calcium carbonate weighs what now? Weighs what? Let's find out. So they're asking us for the mass of calcium carbonate. So now remember we have to get our question. We have to solve our question by knowing what the equation is giving us. So calcium carbonate now, calcium is what? 40. Calcium is 40 plus carbon is what? Carbon is 12. Carbon is 12. What about oxygen? Oxygen is what? 16. 16. But how many oxygen do we have? We have 3 oxygen. So that will be 16 times 3. That will give us 48. And total will give us what? Total will give us 100 gram. So 1 mole of calcium carbonate weighs what? 100 gram. So we're having 100 gram here. 100 gram. If we are having 2 mole, it will be 2 mole, it will be 2 times 100. But since we're having just 1, that will be 1 times 100. This is just, so 1 times 100 will still give us 100. So now, since we have gotten what we'll make use of now from the equation now, let's now apply the question. Let's now go into the question. Let's now solve for what they're asking from us in the question. So we can see that 100 gram is 100 gram of limestone react with ACl to produce what? 22.4 dm cube from this equation. Now what's the question now? What volume of CO2 is produced at STP? What volume of CO2 is produced at STP? So that will be what? X dm cube. When 50 gram of limestone. When 50 gram of limestone. So we're having what? 50 gram here. So what's the next thing here? We do what? Cross multiply. Cross multiply. So we're having x equals to what? 50 multiplied by what? 22.4 divided by 100. So when we divide it, we get x equals to what? 11.2 dm cube. That will be our final answer. So it means that when we make use of 50 gram, we get what? 11.2 dm cube of CO2 being produced. Now, our equation confirms our answer. Our equation confirms the answer. How? Because from the equation, we can see that 100 gram produced 22.4 dm cube of CO2. If 100 gram produce 22.4, then half of 100 gram we also produce half of this one too, which is what, 11.2 dm cube. So that is for number 1. Number 2 now. Question 2 says that calculate the mass of zinc sulfate produced when excess of zinc carbonate is added to 50 cm cube of 4.0 mole per dm cube of H2SO4. We are given zinc sulfate to be, that's the molar mass of zinc sulfate to be what, 161 gram per mole, and we are given the equation here. So the equation now, zinc carbonate reacting with H2SO4 to liberate. So it's producing zinc sulfate, carbon 4 oxide, and H2O. So let's check if it is balanced. 1 zinc, 1 zinc, 1 carbon, 1 carbon. We're having 3 oxygen here. We're having 4 oxygen here, making 7 oxygen. Let's check. We're having 4 here, 2 here, making 6, and 1 here, making 7 oxygen. So oxygen here is balanced over hydrogen. We're having 2 hydrogen here. We're having 2 hydrogen here. We're having 1 sulfur here. We're having 1 sulfur here. So the equation is a balanced equation. Now, we're having the question here now, which you have to calculate. Now, how will we go about the question now is by getting what we are going to make use of from the equation. Now, the question is based on what substance and what substance. Let's check. Calculate the mass of zinc sulfate. So we're having a question on zinc sulfate. So zinc sulfate is the unknown here. So this is zinc sulfate. Zinc sulfate. Zinc sulfate produced when excess of zinc carbonate is added to 50 cm cube of 4.0 mole per dm cube of H2SO4. So the value for H2SO4 is what? 50 cm cube of 4.0 mole per dm cube. So this is the value for H2SO4. So now, H2SO4 is the second substance that is having value. The first one is the unknown. Second one is the one having value, which is H2SO4 in this case. So we have H2, H2SO4, H2 zinc sulfate, H2SO4 and zinc sulfate. So now we are seeing H2SO4 having a value of what? 50 cm cube of 4.0 mole per dm cube. Now, this value for H2SO4 means what? Let's find out. Now, the question here is we're having 50 cm cube of 4.0 mole per dm cube. So please, let me teach you how to go about something like this. So what here is telling us is that we have to look for the amount of 50 cm cube in 4.0 mole per dm cube of H2SO4. Now, since here is cm cube, we have to look for this value here in cm cube. So please take note. 1 dm cube equals to 1000 cm cube. 1 dm cube equals to what? 1000 cm cube. So it means that we are having what? 4.0 mole in what? In 1000 cm cube, which is what? 4 mole in what? In 1 dm cube, which is 4 mole per dm cube. So we're having 4 mole of H2SO4 in 1000 cm cube. So now, what do we have here now? We are having what? 50 cm cube of 4 mole per dm cube. So we are having what? So our 50 cm cube will be here. So we are having 50 cm cube in what? So how many mole are we going to have for 50 cm cube? So we're having x mole. Cross multiply. So we're having x equals to what? 4.0 multiplied by 50 over 1000. So we divide further, you get 4 times 50, you get 200. 200 over 1000, that will be what? 0.2 mole. We have what? 0.2 mole as what? 50 cm cube of 4.0 mole per dm cube of H2SO4. So 0.2 mole is the value of what? H2SO4. So that is for this. Now, from the equation now that we are going to make use of to solve our question, we are having 1 mole of H2SO4 producing 1 mole of zinc sulfate. So are we going to leave the unit here as mole, or we convert it? Now we have to calculate zinc sulfate in mass. The question says that calculate the mass of zinc sulfate. So we are calculating zinc sulfate in what? In mass, not mole. And we are already given the mass of zinc sulfate to be 161 gram per mole. So 1 mole of zinc sulfate weighs what? 161 gram per mole. So we have 161 gram. If you write gram per mole, it's still correct. So from the equation, that we are going to make use of to calculate our question. We are having 1 mole of H2SO4 producing 161 gram of zinc sulfate. So now, what's the question now? Calculate the mass of zinc sulfate produced. So we're having x gram produced when excess of zinc carbonate is added to 50 cm cube of 4.0 mole per dm cube of H2SO4. Please don't get confused. The value here is not for zinc carbonate. The value here is for what? H2SO4. We have 50 cm cube of 4.0 mole per dm cube of H2SO4. And what this one means is 0.2 mole of H2SO4. So we are having 0.2 mole of H2SO4 in what? 50 cm cube. 50 cm cube of the solvent. So our value here is what? 0.2 mole of what? Of H2SO4. So what does that mean? We are calculating H2SO4 in what? In mole. In mole. So we are having 0.2 mole here. So we are having 0.2 mole. 0.2 mole. 0.2 mole. So if we make use of 0.2 mole of H2SO4, what mass of zinc sulfate will be produced? We have to calculate the mass of zinc sulfate that will be produced. So cross multiply. So we're having x equals to 0.2 multiplied by 161 over 1. So our x equals to what? Y is equals to 32.20 gram. If you write gram per mole, is still correct. So when we make use of 1 mole of sulfuric acid, we get 161 gram of zinc sulfate being produced. When we now make use of 0.2 mole of H2SO4, how many gram of zinc sulfate to be produced? So we have 32.20 gram of zinc sulfate produced. We use 1 mole, get 161. When we make use of 0.2 mole, which is a much more smaller than 1 mole, so we get a smaller mass of zinc sulfate produced, which is 32.20 gram. So that is the final answer for number 2.